Thank you, and welcome everyone. Happy to see a new cohort of VCA. Some familiar faces already, and with some of you I already talked on one-on-one sessions, and yeah, you're also welcome to schedule one if you haven't. Really enjoy having some conversations with the residents. So yeah, let's start. Let's start with a few words about myself. So I'm coming from a background that combines AI and photography, and I've been doing been in those two fields for quite some time. I had an analytical background where I started by studying mathematics, then doing a master's in mathematics, and afterwards doing a PhD in computer vision and artificial intelligence at Polish-Japanese Academy of Information Technology. So this was my very analytical and technical side. But at the same time, I also pursued my passion in photography, and I've actually been also during that whole time working as a part-time event and documentary photographer. So there has been a lot of different experiences that led me to discovery of this new field that, for me, AI art and even speaking broader, joining in some ways the technology and art and different tools, different methods, different computer tools that would allow me to express myself creatively. This led me to the practice that I'm doing today. So yes, today I will do some intros to the general understanding of AI. What are the common misconceptions about AI? What are the most popular types of AI? Some of the words I'm sure you have heard of, but maybe they are just buzzwords for you. Don't really be afraid if some of the stuff sounds technical. I will try to explain as easily as possible, but of course, if anything's unclear, you're free to ask questions. And my goal essentially is to shed some light onto what lies behind all of those buzzwords that we currently hear, Gen AI and LLMs, and also the second goal would be to maybe inspire some of you, the ones especially who are more based in traditional art practice and traditional mediums, to maybe go on and pursue some more experiments with this technology and maybe find some tools that could be an interesting path for you to explore. So first of all, what is artificial intelligence and what is it not, more importantly? We hear this term mentioned so much, but one thing to realize is that what we call AI is not really as scary as it seems. It's definitely not something as mysterious and as scary as many of the media outlets like to put. As artificial intelligence, essentially nowadays we call all the methods that use neural networks. So neural networks don't sound as scary as artificial intelligence, but also they don't really sound as buzzworthy. So maybe this is why the newsletters and articles don't like to use simple terms. They like to scare us quite a lot. But of course, not to say the results that those methods from deep learning and machine learning, especially with the breakthroughs in the last 2 years, what they're able to achieve, it's absolutely astonishing and impressive. And the technology is definitely evolving at such a quick pace that is, of course, important to take a step and take a moment to think about the tools we have on our hands and also on how we can use them. So this is true for all AI tools that are out there, whether it's vision tools, text, sound, but AI tools will only be as good as data. And what artificial intelligence does under all those complex mathematical formulas is actually just learn from data. There is even one way of describing AI models as very smart compression machines. When you think about it, DALL-E or Midjourney is a compression mechanism for kind of all the information that was available on the internet up till the point when authors trained the models, and it just compressed to 2 or 3 gigabytes of storage. So that's definitely impressive. But this also means that, first of all, the AI models have no knowledge outside of the data. They are able to create absolutely original connections within the data. They have this sort of this sort of creativity that is not a capital C creativity, but it's somewhat interesting to how it combines different concepts, how it is allow us to also explore different themes. And AI models will only be as good as the training data. So whenever you engage with AI model, I would usually advise to think about what data does this AI model use? Because this question will give you an answer to what is possible to do with this model, essentially, and maybe even give you some creative directions. So if you're training your own model, the first step would always be think about the data, think about the data you can gather, think about the data you have, or maybe the data you don't have. Also, when you think about the data, think about the problems that are in this data. Is this data copyright free? Is this data clean? Maybe it's messy, maybe it has some noise, it has some biases. In real life, data is always messy. There are very, very few exceptions where this data is super clean. And it is actually very often that in artistic projects where artists have the time and the capacity to create those smaller data sets that are so much more curated and so much more clean than it is often in research or an industry. And another thing, very important one to realize when working with AI is that the rules are something that is a magic sauce that happens when AI model is learning. So this magical data that I'm mentioning all the time serves as learning material, and then models aim to figure out the rules. This means that we don't just say to AI, well, this is how the world looks like. This is the human has 2 hands and 1 head. But we just allow AI to kind of look at the images and figure out on its own. So this is also why, for example, those mistakes happen with people who have 6 fingers or 3 fingers or different numbers of them, is that we never tell AI that, well, human can only have, 5 fingers on 1 hand. But by looking at the images, there is very often different types of occlusions. You can see handshakes where different fingers from different people kind of collide. And it's all in these examples that AI is trying to build a statistical model of the world and kind of say, okay, so most commonly people have 5 fingers, but there's a handshake, something, maybe I might see 7 fingers, right? Or maybe someone is holding a flower and I can only see 4 fingers. So there are many different use cases that neural networks see in the data, and then afterwards those rules are fuzzy rules that emerge on kind of its own when the model's been learning to generate this vision of the world, which in no ways is an exact replica of the training data that it has seen, but it is a sort of a compressed way of seeing this whole world of data that we've shown during training. And another important distinction actually about AI methods And also a very common misconception that I hear as LLMs become so popular, and also DALL-E, Midjourney, and Diffusion are the tools that are most spoken about. It is a very common mistake to think that all AI uses text. But it is, of course, not true. There are different kinds of AI tools, and sometimes they're so different among each other, more than similar among each other. So when we are talking about using AI tools for visual signal generation, such as image generation, there are two main categories of AI tools that we can speak about. So the one on the right are the clip-based tools, so those that use text, and the ones on the left are the GAN-based methods. So these would not be using language in any ways. And as you can see, there are multiple methods, multiple models that employ different ways of how to build an architecture that would do that. So how can we build a model that would understand text? There are just so many different ways, and also so many different ways on how we can build AI that doesn't use text, but just looks at the visual signal and tries to replicate that. So now we will talk in a little bit more detail about two of those main categories, and we'll start with the most popular one. So all the text-to-image tools are actually building upon a very powerful language and image understanding model, which is called CLIP. And what this model is able to do might sound very simple to us, as it's just connecting text and images. So when we have an image of a cat and we have a cat written in English language in 3 letters, it's quite natural to us to understand that those two, they relate to the same concept. But of course, up till CLIP, there were usually in AI different models that worked with text and very different models that worked with images. So that was kind of a huge breakthrough when OpenAI was able to create this huge and powerful model that suddenly was able to very successfully connect text and images in such a way that suddenly it was possible to build models that would have those kind of connections and would be able to go from text to image or going from image to text. And this clip method had some very interesting technical details that authors introduced, so that was a great breakthrough. But also a huge part of this power comes from the fact that they were able to train an absolutely immense network with a huge number of parameters on a huge data set that had almost 500,000 of pairs of images and text. So it was, again, just a case of showing data, showing examples of words and images and telling AI, look, this is a word, this is an image, connect the two. On a very conceptual level, it's a simple method. But of course, the technicalities are quite difficult to grasp, but they're not really that important for us. And afterwards, it was just natural to go to the next step of creating images from text, as of course creating text from images was a task that was somewhat solved already and was not as interesting, but creating new images from text was a fascinating task that OpenAI started solving first with DALL-E, and then with the more popular version, DALL-E 2. And another invention that they applied to this method that is also used in all the other tools that you see is called diffusion. And the way diffusion works is that it tries to reconstruct image from an absolute noise. And what it also means is that even when you use initial images, they are treated as noise, and it is then going in a step-by-step process, applying some more details and trying to get back to the full quality. It also means that the task of reconstructing images from an absolute noise is, of course, a task that is kind of ill-defined. When we see an absolute noise, there are many possibilities of how this image could have looked like. So this is why, of course, it's a process that never really has a one correct answer, and this is why the space of all the reconstructed images is quite a huge one. So when you're using a tool such as DALL-E 2 or any other text-to-image tools, there is actually no training of the model happening. So when you go to those websites, you're not training the model, but you're engaging with the model that somebody else has trained. And even if you're using an initial image, even if you're using a few initial images, changing the parameters, and you wait for a long time for the image to generate, the fact is that what is happening behind the scenes is just inference, so there is no model training, and the weights have been frozen. So the authors of this tool trained their AI on a huge collection of images and texts, and now they allow others to engage with this model. Which also means that it's not really possible to engage, add any new information to the model that was not present there before. This is why, for example, there is this knowledge cutoff. So when you're trying to generate very recent events, of course, those models would have no knowledge of those, as they've been trained on data sets that have been collected up till 2020 or 21 or any other cutoffs. And Midjourney is actually a proprietary model, so there is not as much shared about the model details. DALL-E is not an open source model, but at least the authors have published a white paper that explains in quite a lot of details how they built the tool. This is why actually Stable Diffusion was able to be created, because they built on the information that was made open source by OpenAI when they did Clip and DALL-E. Judging from the outputs that Midjourney is creating, there is a few facts about the model training that can be deduced. So first of all, this is also a diffusion model, as it works in a very similar method to DALL-E and Stable Diffusion. It first has this noise, and then iteratively in each step we have less and less noise for a number of steps as long as you go. Of course, when you allow it to inference for too long, too many steps don't always mean necessarily better quality, but it means that model is trying to add something new to the image. Midjourney also has a very particular data set, I guess, as they have quite nice textures, and also they used a lot more artistic focused imagery. My guess is they used a lot of photographs, a lot of paintings, and they really curated their data set not to have too many general looking photographs taken from the internet, but having more artistic quality. Of course, it doesn't mean that the outputs are always of higher artistic quality. Every tool has its shortcomings, because with some of the newer Midjourney model, at least subjectively for me, it seems that the textures are even too smooth, and the outputs look too polished, too airbrushed. But of course, many of those things are quite subjective, and as an artist, you're you of course encouraged to try all the tools and see how you can make them work to your liking. Similarly, there is no training. The optimization happens directly on the trained model. So Stable Diffusion is the most open source tool, and the weights are made open source. The code is made open source. So it's something that has been very broadly experimented with in the artistic and creative coding community, as of course many people were able to train their own versions of Stable Diffusion. I'm sure you're familiar with many new variants, many new models that became popular within the Stable Diffusion. So yeah, that's amazing. But of course, the initial model, you still need to be mindful on what it was trained on, as there is this most popular data set that in the beginning DALL-E and Stable Diffusion used that contained a lot of copyrighted information. I'm not sure if the further versions of the data set still have, for example, Getty images, or have they removed that? But I guess that with every new iteration of the model, they will have it created better and better. So moving on to the next subtype of AI models is GAN, which is a tool, a method that was introduced way before diffusion and text-to-image, and generative adversarial networks were actually invented in 2014. And this is a way of showing neural networks examples of a data signal and then aiming to replicate that. So there is a nice comic by Nod-Radek that explains intuitively how GANs work. So in every GAN, there are two networks, one that is called generator, or colloquially forger, artist, the one that creates the images. And the other one is called discriminator, or critic or policeman. Its role is to judge the images that were created and to tell if they're good or bad. So as the training progresses, the generator is creating some random images, some better, some worse, but it gets a feedback from the discriminator that is saying, well, this one is terrible, but this one is maybe better. Actually, this part in the left corner, you got it quite right. So it gets this kind of signal back from discriminator that essentially allows the generator to learn better, and with every iteration to create something that is more and more similar to the original data. Of course, as generator gets better, the policeman's job is also more difficult, as at some point it is not even able to distinguish the real examples and the generated examples. So it also has to improve, and it has to look more into details. It has to look more into the logic behind the image. And this is why, as the training progresses, we're able to capture the initial data distribution quite well. GANs are usually trained on smaller data sets, which is why they're more friendly for artists. And there are some different types of style GAN that require as little as few hundred or few thousand images. As a reminder, text-to-image tools usually require like 500,000 to be trained from scratch, so that's a huge difference. Of course, there are ways to fine-tune models with smaller amounts of data, but essentially there is this huge data gap required for both kinds of AI models. And when you've tried your first experiments with the AI, when you've tried maybe running some tools, the next question that often comes to mind is, well, maybe I should train my own AI model, and especially GAN, as it requires less data. So when proceeding to train your own model, I would suggest to start with the questions, especially to start thinking about what is your goal, what is your theme in your data, and also about what are the shortcomings, possible negative aspects of your data that you might want to avoid. As curating the data, going back to the beginning of this talk, is the most important part, of course. First of all, when you want to train a new model, when you want to train on your images that are very different from everything else that you've seen in different models do, I would usually suggest to start with a bigger data set of, let's say, 1,000, 3,000 images that might be coming from your archives, from your artistic practice through the years. And then when you have this first model, what is actually pretty cool is that for the next models, you don't really need that much data, as you can do what is called fine-tuning and take an older model and just train it on a much smaller data set to kind of adapt the previous model to the new data. And for that, you usually need like 100 to 300 images. Of course, those images need to be well curated from a visual perspective, as sometimes, for example, here we have a concept, actually Google Images result search related to Africa. And when we look at it, it's to us, it's of course quite obvious that there is one theme within this collection of data. But for AI tools, it's usually a mix of different themes, as the methods, the visual methods, they usually work by establishing patterns, by establishing color palettes first, by establishing textures. And in such an example, if we were to train an AI model on Africa, we would get an absolute mix of something that doesn't look like anything at all, because such a model would try to mix maps with photographs, with portraits, with landscapes, everything in between. So I actually provided two examples of data sets that were very well curated, coming from two of my collaborations that also have shown very distinctive visual characteristics. So the first one, coming from Flora Solaris series, as you can see, the color palette was very restricted, also focusing on close-ups of the flowers. And even if we have a bee in the upper right corner, the AI model would just assume it's some kind of part of organic growth and not really get confused by that. And in the second example, it was street photography coming from neon close-ups. So here again, we see that there we actually mixed two different viewpoints. Some of the images contain close-ups, while some of them are taken further from the street level. But again, we just had two different perspectives, not more, and only focused on images taken during the night and with some bright, vivid colors, which meant that it was a task for AI that was quite easy to learn, and very quickly it was able to grasp how to recreate the most characteristic patterns. And when you train your own model and you want to train your first one and you don't really have anything, what is actually really useful to do is to start with some pre-trained model. And NVIDIA, which is the author of the style GAN subtypes, actually shares quite a lot of different pre-trained models. And those contain different plans, but also trained on paintings and cells images. So if your data set has at least some similarity to any of the pre-trained models, what works very well is to start with this kind of model. So if you have, let's say, drawings, your own drawings of portraits of people, you could start with a model that already knows how to create faces, and it would quite quickly converge to your data. So this is always a good idea. Yes, so actually, I also wanted to show a bit more about how GAN training works on a particular example of a project that I did. So this is like a very short video that I will now run. So every GAN training starts with photography. So you saw some examples of photographs that I used for Mem Discontinued project. And then after, when AI is training, it's actually quite boring to watch, just a bunch of numbers. And what is also interesting to do, you can force AI to forget by showing it a different data. So you can see here as one visual data transforms into a very different one that is more abstract. So this is essentially how GAN training works when you're doing fine-tuning. And then when you have a trained model, you're able to prompt it for different images. And as it's not using any text, you're just moving in different directions in the latent space. Where one way of understanding that would be that in 3D space, we can move left, right, or forward and backward, and every step would give us a very different image. So this is essentially of the way of working with GAN training, and also creating the images and animations. Something I do very often. So yeah, if anyone was interested in working with animation medium. Yeah, so now just like to also quickly mention that not many people realize, but AI is not just images and text, but there are also tools for generative sound. And there are some tools that don't require coding that you can try. The one that I like to play with is Beethoven. It just allows to choose different moods, different kind of instruments. It's not very advanced, but if any of you are interested in sound generation, there are some more advanced tools also on technical level. The ones that allow you to train, for example, your own neural network on your library of sounds. So yeah, it's not a popular field, but I would be very happy to talk to someone if someone is curious to explore this field. And also, what is really nice about sound is that you can combine, you can actually do both. You can do audio-visual, you can do audio-reactive visuals. And so, for example, you can control the pulse motion. You can input an audio track and a trained GAN model, and then get a video that reacts to sound. I'm not sure if the sound is playing, but then afterwards you can also look at this and see the sample result of how it looks like. Yeah, so essentially it allows for a lot of interesting experimentations and creating visuals with GAN models and playing with sound, and yeah, definitely very cool to check out. It was called Lucid Sonic Dreams, if anyone's interested, if you had a GAN model and soundtrack and you wanted to combine the two. And finally, some tools for super resolution is actually a separate field for upscaling images. It's a separate AI domain even that very often has separate AI models to doing that. And the most popular ones currently are SRGAN and SwinIR, and the tools such as Gigapixel, Topaz, Let's Enhance IO. They essentially have some fine-tuned versions of those models that work quite well on natural photographs and paintings and even on some generated images. So now there are also diffusion-based methods that work quite well, and this is what you would see in those tools like Midjourney or Diffusion, where it asks you about upscaling. So this is usually applying a different model to enhance the image behind the curtains. And one thing I've noticed, which is actually quite curious, is that GAN outputs, they don't always look good with upscaling methods, but one trick to do that is to diffusify the GAN output. So let's say use it as an initial image and only allow 1% of diffusion to happen on top. So have the diffusion work with like only slightly. And for human eye, the difference would be not really visible as the image just changes very lightly on the texture level. But then such images are great input to those tools like SRGAN, SwinIR, and latent super resolution. And yeah, finally, some links. So that for those of you who are interested in GAN training, I would recommend using Runway ML. If you don't have any coding experience, you don't want to look at code and you just want to do your first experiment, it's a great platform to just drop a bunch of images, select a few settings with sliders, and have your first GAN model trained. If you're a more advanced user, then of course going to StyleGAN 2 or StyleGAN 3 repository from PyTorch is probably the most easy to use and just running your own training. But for that, of course, you would either need cloud or your own more powerful computer. StyleGAN is, of course, not as resource consuming as Diffusion. So if you're able to run Diffusion locally, you would be, of course, absolutely able to run StyleGAN as well. Playform is an older tool, also for the old school tool Deep Dream Generator. Some of those tools are not as frequently used, but I found that many people really like to go on and explore the new methods, the next best tools, but not always those next best tools are the best, and sometimes you can get really interesting results when using some older tools and really exploring a particular theme or topic, and not with the goal of finding a perfect replica of your data set, but more of us exploring some common patterns or features that happened within your data. So this is, of course, a very interesting question and theme on its own. Yes, so some guidelines. Well, if you want to train your own model by not using Runway ML or not using a model that somebody else has trained, and you want to gain this technical knowledge, so what you essentially need is to learn some basic knowledge of command line. Usually, you just need to run a few lines for training of those models. To navigate GitHub, install libraries. Most of the stuff in AI is written in Python. Fortunately, Python is probably the friendliest coding language out there, and it's really quite natural to understand and probably the easiest out of those. So if you wanted to learn coding, and you wanted to do some AI, I would recommend maybe learn some basics of Python. And then there are some libraries that implement all the difficult blocks of how is the optimization happening, how are those architectures implemented. So the things like TensorFlow, PyTorch, NumPy, OpenCV, they are all libraries that implement all those difficult building blocks behind the scenes. And also, if you don't have a GPU card, there are tools such as Google Collaboratory, AWS SageMaker, and others that allow you to just pay per use and don't invest in hardware. Finally, I'd like to finish with some of the thoughts on AI art community etiquette that I believe somehow emerged through the years. And those are some good guidelines that I've noticed people doing, and they are very encouraged, especially nowadays as AI imagery is becoming so prominent. I feel that if you're using a model that is not your own model, but something that you're using out of the box, it is seen as a nice gesture if you credit the model, especially if you're using something that is open source. So a lot of the AI research is built upon the open source that is published before. So this is how a lot of the quick pace and progress has become possible. Also creating data sets. If you don't have your own data, there is actually so many available copyright-free data sets that you can use. Be careful to read the fine line on platforms such as Pexels and the other copyright-free images, because sometimes they disallow AI training. I think they introduced that just recently as AI becomes so popular. So yeah, be careful to see if the data is possible to be used for AI training. But for example, for a recent project I did, I used Hubble telescope images, which were just astonishingly amazing, high-res photographs of galaxy, and they are free to use under free license commercially, however you like. So yeah, there is so many amazing data sets that you can find. Curation, I believe, is also quite important within the usage of AI tools, especially when we are using text to image. We can generate so many images, and I believe that the role of curation is becoming even more important. It doesn't even mean that you just need to cherry pick the outputs that you like most. The curation can also happen on a deeper level when you're curating a model, when you're curating the parameters. Maybe you're even doing a long form AI model, which means, of course, that the curation would be even more difficult, as you want to make sure that most of the outputs, or like 99% of the outputs, are what you like. And yeah, the data, again, be aware of potential biases, of course. The AI works by augmenting stereotypes. There has been some studies done that showed, for example, that if there is like 20% bias in training data, in the generated data, it will be 40%. So it really augments the biases, whether it's human biases or maybe just as simple as color biases, texture biases. Yes, so if you create a data set and you think that you include a little bit of some images, they might not even be picked up by model. And yes, so I guess this is all. I also include some links. I will share the link to the slides for anyone interested. And thank you so much for listening. I'm open to any questions about AI, about general practices, maybe your own experiments. And I'll just post the link now. Yes, so we have a question from Dave about training a text-to-video model. So yes, this is what's available also on Runway, the tool I mentioned for GAN training, but it's of course so much more than that. They just introduced their second generation of text-to-video model. In my very subjective view, those models are still quite limited in a way that if you have the narrative, it is still quite basic, and it requires a lot of processing to be able to achieve really good results. Also, there is one problem with most of the text-to-video models is that they use diffusion, and diffusion is not really great for video. So when I explained in the beginning how diffusion works, is that it takes noise and then generates something that is high res. And in video, it would start every frame with different noise or the same noise, but it would converge to different things. So what happens is that the frames, they get shaky. So this is the effect that you very often see in AI-generated videos with the diffusion, is that from frame to frame, some details might change, which is not really coherent. When, of course, it's possible to do great videos and to reduce this effect to minimum, or maybe amplify this effect and assume this is the artistic quality. But diffusion is not really made for videos from a very low level, how the architecture is built. Of course, there are some workarounds. You can make the video smoother. You can do frame interpolation to reduce this kind of effects. And this is what they are doing at Runway. And right now they're producing state-of-the-art text-to-video. So this is what you should be looking at if you want to explore that. Pavel, thank you so much for the feedback. And there's a question about compute power. How much power did you use? Yes, so essentially I train my models on cloud. Most of them using 1 to 4 Tesla T4s. It's for training. Then for the inference, I also would use one GPU, but for the inference, it would just run for like 1 second for one image. And then when I create videos with GANs, it's like 3 minutes on one GPU. So, and how long to train the model, it would actually be very different for different kinds of models. A vanilla style GAN ADA would give you good results in like 1 day on one GPU. So it's not really bad, and it's not really expensive. Definitely not comparable to training your own diffusion. That would take you like a month on several dozens of cards. Of course, there are tools to fine-tune diffusion, which is different, which is what, for example, Dreambooth is doing. But what it does, it takes trained diffusion, and it doesn't really infuse that with your text. It just tries to find the images that are most similar to the ones that you have in the model that was trained already. I have another question from Espinosa. Do you think artists using Midjourney is problematic or potentially problematic? Well, so I mean, it really depends. One problem I usually see is when people just bluntly use an artist's name. This is something that is pretty straightforward. It is similar to pastiche, where you just try to copy somebody else's talent. You don't even need Midjourney to do that. If you took all paints and copied somebody's style, it would be a painting, but it would not really be art. And right now, the difference is that it's really just so much easier to do these kind of pastiches. But if you use Midjourney creatively, if you use it as part of your practice, or maybe you use some elaborate prompts and you develop a style that is so much different than what other people are doing. And you're not copying anyone else's style, or maybe using a long list of different artists that essentially in the output, it's not like single one of them is easily distinguishable, then of course it's a different question. So yeah, the answer is it depends, and of course it can be both problematic or not really be problematic. This is why you need to be careful as an artist when you use those tools. Make sure what kind of data is there, what kind of prompts are you using. Are you not maybe by chance copying someone? It's also possible those tools that you're not even using some other artist's name, but your work looks like their work, and now you have accidentally kind of copied somebody. So yeah, just be careful. Another question from Emily: have you played with Meta AI? So with this one, I haven't really played with this particular one. Devi, yeah, I like Devi's work in general. So I'm sure she had some great results with this tool. But yeah, there are just so many of those tools that come out all the time. It's good to check them out to see if they fit within your practice. In my case, it didn't really fit my practice of training on my own images and then having very more abstract like animations. But if it fits your case, I would definitely encourage you to check it out. It looks lovely. Okay, thank you, Dave, for feedback regarding Runway. And yes, there are definitely some results and limitations, but yeah, it's also possible to definitely have nice results. Oh, okay, great. It's true with every tool, of course. And I believe that it's important to know the shortcomings of the tool so that you use it well and you use it where it's strong. This is how you're able to achieve really interesting results. Okay, and another more question from Emily. What project artists have you seen recently that you're excited about now? That's a great question. To be honest, I'm super excited. So many new people coming from different backgrounds into AI, and it really feels and it's easy to see when someone who has this understanding of art and of different mediums comes into AI art, and they're able to transform their understanding of the world around them and their emotions, and really to feed that. I won't name any names, as I would feel quite bad that I omit some of them. But what I did actually is I did a few open calls for Nifty Gateway AI art show, and I was just amazed to see there's so many names I didn't know and I haven't seen before, and to really have those new names appear and some new people coming to the practice, and really from such diverse backgrounds as well. This is what's most interesting, I guess. And what's next for AI art? That's a very difficult question, of course. Those methods will get better. There will be exponentially more AI methods, exponentially more to choose. I guess we might come to the point where AI models would be like camera types, and some people will have their favorites. Some people would be experimenting with new ones all the time, experimenting with next best thing. But it will also not even be possible to try every AI tool that is out there. So they might become more focused. So you will have those artists specialized in, let's say, these kinds of AI models, and different artists specialized in different kinds of AI models. So maybe you will even have like different names for that. So there will be like diffusion artists, and then like optimization artists and not even using AI tool anymore as it becomes so broad. In a similar way, how we no longer use the term computer artist, as computer art can be everything. It can be generative art, it can be JavaScript art, it can be Adobe art, it can be AI, there's just so many subtypes of that. So I guess that might be the next thing of how it grows. Another comment from Ivan about DALL-E 2 and Adobe Firefly. So your goal was to create reference images for you as a model so that you could draw them by hand. Yes, interesting. Create me a computer made of seashells in isometric view. Yes, so that's the problem also with many of the text-to-image tools. And AI today in general is that we see those fascinating use cases, but they're often quite broad, right? When we think of a cat on a skateboard and AI generates something, it corresponds quite well to our query. But when we want something super specific, super specific, down to the details, once you experiment with those tools, you realize it's not that easy to do and to get down to details without, using external tools, post-processing, Photoshop, etc. So for Ivan, actually, I think what might be interesting for you is to use ControlNet. So ControlNet is the kind of also twin method that allows you to go from one distribution to another. So for example, you might be going from drawings to paintings, or you can go from isometric views to photographs, and then when you train such a model, you would be able to get something that would be more useful in your creative practice. It's a somewhat similar to pix that you just train AI to transform one kind of imagery to a different kind of imagery. So maybe try checking that. Yes, is there any? Okay, thank you so much for that, for those amazing comments. Our time is running out, so I will just answer the last one from Carolina. And yes, the ControlNet, Ivan, is this one. You can also try Googling for user-friendly implementations, but yeah, it's essentially this kind of controlling of diffusion models. And the last question from Carolina that I'd like to end with is whether you can use, so what is blend comment in Midjourney, and is it like making a minigun? So the answer is no. It's a very common misconception about GANs and diffusion models in general. So yeah, what happens in Midjourney is you're not training anything. What happens when you use blend is that it takes different images and it finds their representation in the trained model. So it's not really training anything under the hood, but it's trying to blend on what it has learned. So it has already the knowledge, but it's maybe trying to figure out is if there is something inside this huge knowledge that would work with the images that you give to blend comment. Whereas if you train again, you would train an AI that knows nothing else apart from your images. So the whole world is your images, and they would extract this information from your images. So those are essentially different processes, and I hope I explained it a bit. Yes, so thank you so much everyone for attending the class, and also for your engaging comments. That was very lovely to see, and I hope you all have a beautiful rest of the day and evening ahead.